And of course, we can always supply initial data, much like data frame, and we can always say give it a list that we can easily express as a manifest constant, manifest data type. We just type and that is our data. Right? So, and let's say that interpret that as int. Okay, now you may see it's obvious, isn't it? Yeah. So then what is SS1? What we'll see is int, and below it says int 32. But if we say, well, because I'm lazy, I just enter 117733. But you know what? Later on, I'm going to add in numbers that are actually float. So I want these to be understood, interpreted as float, and it's okay. It's okay. So if we do this, we actually see the dot zero coming out. And just to also give it a bit of a contrast, if we say the D type is string, because I'm lazy, I don't want to code and uncode all the one. They are numbers, but actually they are block labels of the flats. So it's actually block 11, block 77. Don't treat it as integer, treat it as string. So I can just do it this way, and it will be okay, right? And you see that it's object here. Yeah. And that basically means it's not computable. It's not a string or it's not an integer or float. Okay, that has got big impact. Why? Because when we do this, okay, and we add with PD of series of 22, 99, and 55, let's say. Okay. Now for addition, our data types need to be the same. It's always a mathematical requirement. Apple adds with Apple, right? So here we have string and string. And if you have string adding to string, what happens? In Python, the string addition is you concatenate. You just join the strings in that order. So we have 1, 1, and 2, 2. So when you do that, it's permissible and it's understood to be element by element addition. It's not like joining 117733 then 229955. It's not like that. So this list addition is basically a scalar addition, element by element. But that's where the data type comes in. So if you're not careful and you do this, then that might not be your original intention because they are integers. For Python, integer addition is just integer addition. So you get 3, 3 and something else, right? So our results is basically pure integer addition. So that's a drastic change in the way the data is being operated on. And this is where you need to be careful, not only just with the series or data frame, but also the data type, right? So it's very important to be in control. So you're always aware, not just that, oh, I've got 117733 typed incorrectly, but what is the data type that I'm storing it under? That's very, very important. Okay, good. So now we have our data frame, and what we can do is we can sort of inspect it, right? So let's say what is the value at I at 3, 2, and the second value I at 6, 9. Okay, let's print them out. Okay, just to verify that your values are the same as mine. Okay, so we're extracting those two out. And that's by absolute integer positioning, right? I at. And it always takes two numbers. Although there are shortcuts, it's best to remember it as row, comma, column all the time. So we can do that. Next is we like to sort of perform some indexing. Okay. So let's try to do that. So what I'm going to do is I'm going to now redefine df. I'm going to redefine df. Okay, the columns, can I get a column right? The columns will be here is the list and my index is going to be also defined on birth, like this. Okay, so basically it's the same, except now I'm going to not only define the columns, giving them a sort of a initial label, but also the index. So it's no longer automatically 0, 1, 2, 3, 4, 5. It will be XYZW 485. So let's see what happens. And we see correctly that it's going to be XYZW 485. Yeah. Okay. Now, what happens if I want to reset? I don't want these bizarre looking XYZW and stuff. I want the labels to be reset. Well, you can always do a df.index equal to range from 0, of course, until the number of rows. The number of rows. So remember, it's always num column. Well, df shape will return to us a tuple. First cell is the number of rows, second cell is the number of columns. So we take the first cell. Okay, so what does that mean? It means that now if we ask what's df, it's everything the same except the XYZW has been reset to standard labels. Okay, so that is useful when we got messed up labels, especially in the indexes when we perform some sort of combination extraction or whatsoever, and we don't like what we see. So that may be duplicated in these index labels, they may be empty index labels, etc., and we can reset it. So that's a very useful statement to run. And again, we can reset the column labels to anything we want. Okay, but it is often a less encouraged thing to do if you set the columns to numbers, integers. Reason is, pandas provides a very convenient mechanism to access columns, only columns, not index, not the rows. Columns very efficiently. So we can say df of b, right? Remember we did that just now, earlier on in our discussion. So df of square bracket selection of the column with the label b gives us the entire column. There's no equivalent easy way to do for row. Okay, so we get the entire column as a pandas series. So this is a series because the series has labels as well, following the labels of each of the rows. Okay, and of course we can assign this to SS2. Okay, and we say what is the type of SS2, and that is definitely the authoritative way to determine the type of the value stored in the variable. And it is telling us it's panda series where the individual datum inside is of data type float 64. Okay, so but even this very nice convention can be made more compact, and this is where panda says if it is a decent variable looking kind of column name, no blanks, spaces in front, funny characters like comma, colon, minus, plus, as long as it's as high quality as a variable name like b, then yeah, I would be able to help you and quickly extract out the whole column, something like that. So again, there's no easy way to do this for the rows, but for columns, this is very convenient when your column names are more or less fixed for now and in future, unlikely to change, you don't want to change it, then you can hard code this column name into your program name. So df.b now becomes part of your program name, right? You're almost calling b, the data column b label, as a function b. You see that? This is like, wow. You may not say wow, okay, so but this is a big thing. And convenience always comes with big things underneath, right? That you don't notice. But I just try to highlight to you. This is a big wow, but super convenient, and you can only do with columns, provided your column names are as high quality as a variable name. Okay. Now I'm not trying to say that if your column names have spaces or commas or plus or minuses, they are low quality. But they are kind of a bit unconventional. We tend not to say name comma age is the column name. We tend not to say that. So when you actually encounter funny column names, maybe it's time to revisit labeling the columns again.